Let us go for this problem. ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಏನಿದೆ ನೋಡಿ, ABC is a right angle triangle with AB is equal to 0.2 meter, BC is equal to 0.6 meter, and angle ABC is equal to 90 degree. A charge of 12 nanocoulomb is placed at the corner B. Find the amount of work done in transferring charge of 6 picocoulomb from C to A. Let us go for this. ಇಲ್ಲಿ ಒಂದು diagram draw ಮಾಡ್ಕೊಳ್ಳೋಣ. So this is a right angle triangle. ಇಲ್ಲಿಂದ right angle triangle ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Okay, and here this is A, this is B, and this is C. So ಅವ್ರು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂದ್ರೆ ABC is a right angle triangle with AB 0.2 meter, this is 0.2 meter, and BC is equal to 0.6 meter, this is 0.6 meter, and angle ABC is equal to 90 degree. This angle is 90 degree. Angle B ಏನಾಗಬೇಕು 90 degree ಆಗಬೇಕು. A charge of 12 nanocoulomb is placed at corner B. So here there is a charge placed. Let us consider this charge as Q is equal to ಎಷ್ಟಿದೆ ಅದು 12 nanocoulomb. 12 nanocoulomb. So what you have to calculate is find the amount of work done in transferring a charge of 6 picocoulomb. 6 picocoulomb from C to A. ಅಂದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಇಟ್ಕೊಳ್ತಾ ಇದೀವಿ, ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅಂತ ಹೇಳೋಣ. So this charge you have to move from, this is a 6 picocoulomb charge. ಇಲ್ಲಿ ಇಟ್ಕೊಂಡ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಮೂವ್ ಮಾಡಬೇಕಾಗಿದೆ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಮೂವ್ ಮಾಡಬೇಕಾದ್ರೆ ವರ್ಕ್ ಎಷ್ಟು ಮಾಡಬೇಕು ಅಂತ ಕೇಳಿದ್ದಾರೆ. So simple question. So how to answer this? First you have to calculate what is the potential at C due to the charge 12 nanocoulomb. ಮೊದಲಿಗೆ ಏನು ಮಾಡಿ potential at C ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. So potential at C is equal to, this is V1 ಅಂತ ಹೆಸರಿಡೋಣ. This can be written as 1 upon 4 pi epsilon naught Q divided by, that is distance ಅಂದ್ರೆ BC ಅಂತ ಬರೀಬಹುದು. So this can also be written as 9 into 10 to the power of 9 into Q ಇದೆ 12 nanocoulomb, 12 into 10 to the power of minus 9 divided by BC ಅಂತಂದ್ರೆ ಅವ್ರು ಕೊಟ್ಟಿದ್ದಾರೆ ಡಿಸ್ಟೆನ್ಸ್ 0.6 meter ಅಂತ. So if you solve for this, minus 9 10 to the power of plus 9 cancel ಆಯ್ತು. 12 nines it is 108 divided by 0.6. If you divide this, this is going to be 180 volt. ಅಂದ್ರೆ potential at C ಎಷ್ಟಿದೆ, that is V1 ಅಂತ ಕರೆಯೋಣ. So this is about 180 volt. Similarly, potential at A calculate ಮಾಡೋಣ. So this can be written as V2 ಅಂತ ಹೇಳಿ. So this is nothing but 1 upon 4 pi epsilon naught. Same charge ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ potential ಎಷ್ಟಿದೆ ಅಂತ ನೋಡ್ಬೇಕು. ಈ ಚಾರ್ಜ್ ಇಂದ ಇಲ್ಲಿಗೆ potential ಎಷ್ಟಿದೆ ಅಂತ ನೋಡ್ಬೇಕು. That is Q divided by, this time distance is BA. So this can be written as 9 into 10 to the power of 9 into 12 into 10 to the power of minus 9 divided by ಎಷ್ಟಿದೆ ಇದು 0.2. So this is 0.2. If you calculate this, once again these two are going to get cancelled here. 12 nines are 108. 108 divided by 0.2. So this is 108 divided by 0.2. This is going to stand for 540 volt. ಹಾಗಾದ್ರೆ potential at A ಇದೆ 540 volt. Potential at C ಇದೆ 180 volt. Potential difference ಮಾಡಿದ್ರೆ ಆಯ್ತು. So this is potential difference. We can write this as delta V is equal to V2 minus V1. So which is equal to V2 ಅಂತಂದ್ರೆ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ 540 minus ಇದಾಯ್ತು 180, which is equal to ಎಷ್ಟಾಗಬೇಕಿದು 360. Okay, so 360 volt potential difference ಆಯ್ತು. ಈಗ ನಮಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ ವರ್ಕ್ ಡನ್. So work done is equal to potential difference into charge. So therefore this can be written as potential difference is 360 into ಇಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬೇಕಾಗಿದ್ದಂತ ಚಾರ್ಜ್ ಎಷ್ಟಿದೆ 6 picocoulomb. It is 6 into 10 to the power of minus 12. Okay, so if you calculate this, your answer will be 6 into 360 ಅಂತಂದ್ರೆ this is going to stand for 2160 into 10 to the power of minus 12 joule. So this is the final answer. Okay, I hope you understood this problem. Let us go for the next one. Okay, now let us go for the second problem, that is charges of 2 microcoulomb, 4 microcoulomb and 6 microcoulomb are placed at the corners ABC respectively of a square. That means there is a square. Assume madona illon square ide. Okay, so this square idralagade ನಾಲ್ಕು ಕಾರ್ನರ್ಸ್ ಅಲ್ಲಿ A B C ಮೂರು ಕಾರ್ನರ್ ಅಲ್ಲಿ ಚಾರ್ಜ್ ಇದೆ. So let us go for this as A, this as B, this as C and this as D. 2 microcoulomb is at A, so here the charge is 2 microcoulomb. 4 microcoulomb is at C and that B, that is illide 4 microcoulomb, and at C this is 6 microcoulomb. Illide 6 microcoulomb are placed at the ABC respectively of a square ABCD of x meter. So the distance is the x meter. So this is the side x meter. Everywhere this will be x meter. Okay. Next, find what charge must be placed at the fourth corner so that andre fourth corner andre ida illi charge estide anta calculate ಮಾಡಬೇಕು. So find the charge at the fourth corner so that the total potential at the center, ಇದರ center ಅಲ್ಲಿ potential ಎಷ್ಟು ಆಗಬೇಕು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು, 0 ಆಗಬೇಕು. So at total potential at the center should be 0. Here V must be equal to 0. So ಇಲ್ಲಿ V 0 ಆಗಬೇಕಂದ್ರೆ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಎಷ್ಟು ಇಟ್ಕೋಬೇಕು ಅಂತ ಕ್ವೆಶ್ಚನ್ ಇದೆ. Okay, let us go for this. ಅವರು ಗಿವನ್ ಅಲ್ಲೇ ಇದೆ potential at O must be 0. ಹಾಗಾದ್ರೆ so we can write V at O is equal to 0. Let us go for the formula of V. Andre potential at V can also be potential at O can also be written as ಏನಂತ ಬರೀಬಹುದು, 1 upon 4 pi epsilon naught potential due to different charges. Ella charges inda bandanta potential due to charge from here. Let us call this as QA, this as QB, this as QC and this as QD. ನಮಗೆ QD the value calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದಾರೆ. ಹಾಗಾದ್ರೆ ಇದೇನಾಗಬೇಕು, QA divided by this distance from here to here. Let us call this as O. That means this is going to be AO plus QB divided by BO plus QC divided by CO plus QD divided by DO ಆಗಬೇಕು. Since it is a square, all these sides must be equal. ಇದು ಏನು point of intersection ಇದೆ, ಇದು diagonal intersection point allide. So from here to here and here to here, these all distances will be same. ಹಾಗಾದ್ರೆ ಇದನ್ನ ಬರೀಬಹುದು VO is equal to 1 upon 4 pi epsilon naught. ಇದರೊಳಗಡೆ AO ಇದನ್ನು ಹೊರಗಡೆ ತೆಗಿಲಿಕ್ಕೆ ಬರ್ತೈತಿ. So bracket ಇಂದ ಇದನ್ನ ಹೊರಗಡೆ ತೆಗೆದಿಟ್ಕೊಳ್ಳಿ, because all AO, BO, CO and DO are same. So therefore this becomes QA plus QB plus QC plus QD. So ಈಗ ಇದು 0 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. So it is already given that at center the potential is 0. ಹಂಗಂದ್ರೆ ಇದು 0 ಹಾಕಿದ್ರೆ we can write this as 0 is equal to ಇದು whole term ಏನಿದೆ 1 upon 4 pi epsilon naught AO ಅಂತ. So ಇದು whole term ಈ ಕಡೆ ತಗೊಂಡು ಹೋದ್ರೆ ಇದು 0 ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ ಉಳಿಯೋದೇನಲ್ಲಿ this is remaining is QA plus QB plus QC plus QD is equal to 0 ಅಂತ. ಹಾಗಾದ್ರೆ QA ವ್ಯಾಲ್ಯೂ ಹಾಕೊಳ್ಳೋಣ 2 microcoulomb plus 4 microcoulomb plus 6 microcoulomb plus QD. So if you add all this, we will get 2 plus 4 plus 6 is 12 microcoulomb plus QD. So if you take this on this side, then QD will be equal to minus 12 microcoulomb. So this is our final answer. The value of charge at D should be minus 12 microcoulomb to make the potential at V 0. Now let's go for this problem. ABCD is a square of side 2 centimeter. ಏನ್ ಹೇಳ್ತಾ ಇದೆ ಅಂದ್ರೆ ಒಂದು ಸ್ಕ್ವೇರ್ ಇದೆ ಆಫ್ ಸೈಡ್ 2 centimeter. So this is a square of a side 2 centimeter. Okay, and let us go for this. The side is given 2 centimeter, so all the sides will be 2 centimeter here. ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ, charges of plus 5 nanocoulomb, plus 10 nanocoulomb and minus 5 nanocoulomb are placed at corners A, B, C. So let us consider this as A, this as B, this as C, and this as D corner. ಇಲ್ಲಿರೋ ಚಾರ್ಜ್ ಎಷ್ಟಿದೆ 5 nanocoulomb, ಇಲ್ಲಿರೋ ಚಾರ್ಜ್ ಇದೆ 10 nanocoulomb, ಇಲ್ಲಿರೋ ಚಾರ್ಜ್ ಇದೆ minus 5 nanocoulomb, are placed at the corners A, B, and C respectively. What is the work done in transferring the charge of plus 5 microcoulomb? So here there is another test charge 5 microcoulomb. Each charge na illitkonda D to the point of intersection of diagonals. So let us go for this. Illinda diagonals draw madidre. So these are the diagonals, and let us consider this as a point. This is the point of intersection of diagonals. Idenide point of diagonals intersection ಆಗಿರೋದಿದೆ. So ಹಾಗಾದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಪೊಟೆನ್ಶಿಯಲ್ ಎಷ್ಟಿದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಬಿಕಾಸ್ ಆಫ್ ದೀಸ್ 3 ಚಾರ್ಜಸ್, ಈ ಚಾರ್ಜ್ ಇಂದ ಇಲ್ಲಿಗೆ ಪೊಟೆನ್ಶಿಯಲ್ ಎಷ್ಟಿದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ನಾವು ಹಿಂಗೆ ಬರೆಯೋಣ, ಪೊಟೆನ್ಶಿಯಲ್ at O, this can be written as VO is equal to 1 divided by 4 pi epsilon naught. We can write this as QA divided by Q andre illiro charge, QB andre idu charge, QA divided by AO plus QB divided by BO plus QC divided by CO. So this side is given 2 centimeter. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಇದು ಪೂರ್ತಿ ಪೈಥಾಗರಸ್ ಥಿಯರಮ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಡಯಾಗೋನಲ್ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ 2√2 centimeter. ಸೊ ಇದನ್ನ ನಾವು ಮೀಟರ್ ಒಳಗಡೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳೋಣ. ಸೊ ದಿಸ್ ಇಸ್ √2 centimeter ಆಗುತ್ತೆ. ಸೊ ಇದನ್ನು √2 centimeter ಆಗುತ್ತೆ, ಇದನ್ನು √2 centimeter, ಇದು √2 centimeter. ಹಾಗಾದ್ರೆ ನಮಗೆ ಬೇಕಾಗಿರೋ ವ್ಯಾಲ್ಯೂ ಯಾವುದು? AO ಅಂದ್ರೆ √2 centimeter. BO is also √2 centimeter. This is also √2 centimeter. Therefore, if you solve for this, this is going to be 9 into 10 to the power of 9 divided by √2 centimeter, √2 into 10 to the power of -2 meter alli calculate ಮಾಡ್ಕೊಳ್ಳೋಣ. So here this is going to be QA value ಏನಿದೆ that is 5 nanocoulomb, QB value is 10 nanocoulomb, and QC value is -5 nanocoulomb. So if you cancel these two, your answer will be 9 into 10, that is 90. ಇಲ್ಲಿ nano ಇದೆ, ಇಲ್ಲಿ 10⁻⁹ ಇದೆ. So this nano and 10⁻⁹ get cancelled. 90 divided by √2 into 10 to the power of -2. So this is our answer. If you calculate for this, 90 divided by √2 ಅಂತಂದ್ರೆ it is about 63.63. 10⁻²ನ ಮೇಲೆ ತಗೊಂಡೋದ್ರೆ it is going to be 10⁻+2. Okay, ಇಲ್ಲಿರುವಂತ ಪೊಟೆನ್ಶಿಯಲ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಹೋಗೋಣ ಪೊಟೆನ್ಶಿಯಲ್ at D. This is VD is equal to 1 divided by 4 pi epsilon naught. Same thing, QA divided by, ಈ ಸಲ ಡಿಸ್ಟೆನ್ಸ್ ಯಾವ ತಗೋಬೇಕಾ? AD plus QB divided by BD plus QC divided by CD. So if you substitute the values, 9 into 10 to the power of 9 divided by, so this and this will get cancelled because AD is exactly equal to CD. This distance AD, this distance CD are equal, and this charge, illen charge ide, idittu -5 coulomb, and this is a positive 5 nanocoulomb. So idu ella seri cancel agi uliyode ಏನು ಉಳಿತದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ. So directly I will write this is QB, that is 10 nanocoulomb, divided by BD distance. BD distance is nothing but 2√2. If you calculate this, the answer will be 31.8. Okay, so this is the answer into 10 to the power of -2 ಬರಬೇಕಾ, ಸಾರಿ +2 ಬರಬೇಕಾ? ಯಾಕಂತಂದ್ರೆ ಇದು ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಇತ್ತು, ಇದನ್ನ ನಾವು ಮೀಟರ್ ಅಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಇದು 10 to the power of -2 ಆಗುತ್ತೆ. So this much of volt, +2 volt. Okay, now let us go for the potential difference. Potential difference delta V is equal to potential at D ಅಥವಾ O minus potential at D. Potential at O is 63.63 minus potential at O, sorry, this into 10 to the power of +2 minus 31.8 into 10 to the power of +2. So if you calculate this, the answer will be 31.8 into 10 to the power of +2. So this is the potential difference. Namak bekagirodenu work done. So work done is equal to potential difference into charge. Therefore this is 31.8 into 10 to the power of +2 into charge ಎಷ್ಟಿದೆ 5 microcoulomb. So 5 into 10 to the power of -6 coulomb. This is going to be 159.1 into 10 to the power of +2 -6. This is a -4 joules. This will be our final answer. Let us go for this problem. In a parallel plate capacitor with air between the plates. Illi plates idave eradu. So let us consider this is plate 1 and this is plate 2. With the plate within the between the plates there is the air. Illi enide anta helta iddaru, air ide anta helta iddaru. Each plate has an area of 6 into 10 to the power of -3 meter square. The area of this is given, that is 6 into 10 to the power of -3 meter square. And the distance between the plates is 3 millimeter. The distance between these two is given, that is a 3 millimeter. Okay. Calculate the capacitance of the capacitor. We have to calculate the capacitance of this capacitor. If the capacitor is connected to a 100 volt supply, so if you connect this to the 100 volt supply, what is the charge on each plate of the capacitor? ಪ್ರತಿಯೊಂದು plate ಮೇಲೂ charge ಎಷ್ಟಿದೆ ಅಂತ calculate ಮಾಡಿ. So let us go for this. Given things is now permittivity of the free space is given, that is 8.85 into 10 to the power of -12 per meter. So let us go for this. Given things note ಮಾಡ್ಕೊಳ್ಳೋಣ. A is equal to, that is area of plate, 6 into 10 to the power of -3 meter square. Next, distance between the plates is given, that is D is equal to 3 millimeter, 3 into 10 to the power of -3 meter, and we have to calculate the value of C. So to calculate the value of C, we can use the formula C is equal to epsilon naught A divided by D. This is for the air between the two plates. So therefore 8 ಇದರ value ಕೊಟ್ಟಿದ್ದಾರೆ, that is 8.85 into 10 to the power of -12 into A ಅಂತಂದ್ರೆ area, that is 6 into 10 to the power of -3 divided by D ಅಂತಂದ್ರೆ 3 into 10 to the power of -3. So this and this get cancelled, 3 1s are 3 2s are. So this is going to be 17.708 into 10 to the power of -12 farad. Okay, so next calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ, what is the charge on this? The charge is given by, actually the value of capacitance can be written as C is equal to Q by V. This is by the definition. So we can write this as Q is equal to C into V. So C value ಗೊತ್ತಿದೆ, 17.708 into 10 to the power of -12 into V is 100. So therefore this is going to be 1770 into 10 to the power of -12, or else we can write this as 1.77 into 10 to the power of -9 coulomb. So this is the charge. Okay, Let us go for this problem. When the two capacitors are connected in series, that means there are two capacitors which are connected in series. To the connected in series and connected across 4 kilovolt line. That means battery connected here is 4 kilovolt. So only 4 kilovolt battery connected is ಇದು C1, ಇದು C2. These are the two capacitors. The energy stored is in the system is 8 joule. And the energy stored ಈ ಕೇಸಲ್ಲಿ ಇದೆ 8 joule. Okay, the same capacitors are connected in parallel. If these same capacitors are connected in parallel, say this is the parallel combination. Okay, so if this is the connection made like this, then C1, C2, the same voltage is supplied, that is 4 kilovolt. Avaga energy stored is at 36 joule. So across the same line, the energy stored is 36 joule. Find the individual capacitance. So we will go for the formula. Formula ಯಾವುದು ಯೂಸ್ ಮಾಡೋಣ ಅಂದ್ರೆ energy stored is half C effective into V square. For parallel combination, for series combination, separate ಬರೆಯೋಣ. First for series, U for series, if you write this is going to be half CS into V square. So if you solve for this is going to be US ಕೊಟ್ಟಿದ್ದಾರೆ, that is 8 joule, which is equal to 1/2 into CS ಅಂತಂದ್ರೆ C1 C2 divided by C1 plus C2 into V square ಅಂತಂದ್ರೆ 4 into 10 to the power of 3, that is 4 kilovolt square. If you simplify this, we are going to get C1 C2 divided by C1 plus C2 is equal to either 2 ಈ ಕಡೆ ತಗೊಂಡು ಹೋಗ್ರಿ 4 ಆಗುತ್ತೆ. Then you are going to get this as, so 2 ಈ ಕಡೆ ತಗೊಂಡ್ರೆ 16 ಆಗುತ್ತೆ. Then it is going to be 10 to the power of minus 6 farad. So let us call this as equation number 1. We'll go for another thing, that is C1. ಈಗ second case ಹೋಗೋಣ, parallel combination ಅಲ್ಲಿ. Parallel combination ಅಲ್ಲಿ energy in the parallel is 1 upon Cp into V square. ಹಾಗಾದ್ರೆ UP is 36 joule is equal to, that is 1 upon 2 Cp ಅಂದ್ರೆ C1 plus C2 into 4 into 10 to the power of 3 square. So if you solve for this, we are going to get this as C1 plus C2 is equal to 4.5 into 10 to the power of minus 6. Okay, so this is our answer. Okay, next again ಮಾಡೋಣ ಅಂದ್ರೆ ಇದನ್ನ C1 plus C2 ತಗೊಂಡು ಹೋಗಿ ಇದಕ್ಕೆ equation number 2 ಮಾಡೋಣ. Substitute equation number 2 in equation number 1. Now it is going to be C1 C2 divided by, this is going to be 4.5 into 10 to the power of minus 6 is equal to 10 to the power of minus 6, or we can write this as C1 C2 is equal to, ಇದನ್ನ ಈ ಕಡೆ ತಗೊಂಡು ಹೋದ್ರೆ 4.5 into 10 to the power of minus 12, or C1 is equal to this is ಅಥವಾ C2 ಡ್ರಾ ಬರ್ಕೊಂಡ್ಬಿಡೋಣ. C2 is equal to 4.5 into 10 to the power of minus 12 divided by C1. So if you simplify this, if you put this C2 value in this equation, ಇಲ್ಲಿ ಇದರೊಳಗಡೆ ಹಾಕೋಣ, equation number 2 ಒಳಗಡೆ, equation 2 becomes C1 plus 4.5 into 10 to the power of minus 12 divided by C1 is equal to 4.5 into 10 to the power of minus 6. Okay, this is a quadratic equation. If you simplify this, you are going to get the quadratic equation, that is C1 square minus 4.5 into 10 to the power of minus 6 C1 plus 4.5 into 10 to the power of minus 12 is equal to 0. If you solve for this, we will have the root of this quadratic equation as 3 into 10 to the power of minus 6 and 1.5 into 10 to the power of minus 6. Okay. So C1 is equal to 3 into 10 to the power of minus 6 farad, and C2 can be written as 1.5 into 10 to the power of minus 6 farad.